In this lecture, we will learn to draw the layout of a 2-input AND gate using magic. So at first, open the terminal window by pressing Ctrl, Alt and T. So this is the terminal window. In order to open magic, type magic and then press enter. Now these are the two windows. This is the layout window and this is the TKCon window. Now we have to grid in. So type grid. So now you can see the small boxes. Shift Z to zoom out, Z to zoom in. Now at first we have to draw the NAND part and then the inverter part in order to obtain the 2-input AND gate. So as we know, we have to create the PMOS and NMOS. So in order to create the PMOS, we have to create a NVL. So select the area and then type paint NVL. And then press enter. This is the NVL, then the P diffusion layer. Select the area and type paint pdiff. Okay, now this is our PMOS. We have to design two PMOS over here, which will be a part of the NAND gate, and two NMOS. So this is my PMOS. Similarly, I'll create my NMOS. Type paint and diff. So now this is my N diffusion layer, which you can see the color, it's green color that shows this is a N diffusion layer. This is my NMOS, this is my PMOS. Now the first thing is to connect the sources of the PMOS to VDD. So since the two sources are shorter to VDD, select the area and then type paint metal. Before that, let me create this VDD layer. So select the area, type paint M1. So as we know, we have to use metal for any metal contacts. Now select this area and type paint M1. Now the VDD of PMOS 1 is connected to the source. Next, connecting another source of PMOS 2 to VDD. So type paint M1. After this, we have to place the contact over here. Since we have the end diffusion layer and metal layer, so type paint. Since this is P diffusion, then P diffusion contact. So we will type paint PDC in order to place a P diffusion contact. Similarly, over here also select the area and type paint PDC. Now, after connecting the two sources to VDD, our next task is to connect the source of NMOS. The source of this NMOS has to be connected to ground. So we have to create a ground layer using the metal. Type paint M1. So this is my ground and this is my VDD. Type paint M1. Now the source of this NMOS has been grounded. Now this is the source of one PMOS, this is the source of another PMOS, and the two gates will be shorted in order to obtain the inputs. Type paint poly. So this will create the two inputs. Type paint poly. So this is gate of one PMOS, this is the gate of second PMOS, this is the gate of one NMOS, this is the gate of NMOS 2. So they have been shorted individually. This is the common drain of both the PMOS, this layer, this region. This is the source, this is the drain, and this is the drain, this is the source for NMOS 2. So the common drain of PMOS has to be shorted with drain of the NMOS 2. So select the area and type paint M1. Paint M1. This much of end diffusion is not sufficient, so we have to extend it. Type paint end diff. Paint M1. Just in order to maintain uniformity, shifting this metal layer towards left, we can see there is only one space here, so I am keeping one space. Then type paint M1 Now we don't require here to here. Select and erase. Let me zoom out. Okay, so this is my NAND gate. Let me place the contacts. Select the area. Since this is the N diffusion layer and above it there's a metal layer, we have to place a contact called the N diffusion contact. So we have to type paint NDC. NDC stands for N diffusion contact. This is my source and this is my drain of another NMOS. Select the area and type paint NDC. After that, we have to place a P diffusion contact over here. So type paint PDC. Okay. So now this is my drain. This is my drain, common drain. This is the drain of the NMOS. We know the drain of PMOS and the drain of NMOS, when connected, they form the output. Now this is the output of the NAND, that is A dot B bar. We can see this is the NMOS in series. So this is A dot B bar. Besides this, we have to place some more active contacts over here. NWC. Since we have the N-well over here, this is the N-well, the black portion, so we have to place N-well contact. We can place some more N-well contacts. Select the area, type paint NWC. Also type, okay, over here paint PWC. Paint PWC. Now we have to place a inverter over here. Type paint N-well. Type paint N-well. Next we have P diffusion, since we have to make a PMOS. That should be always uniformity in your layout so that it looks good. Okay, now it's two from all the sides. Type paint P diffusion. You can see there is so much uniformity. Now, for designing a inverter, we need only one PMOS and one NMOS, where the source of the PMOS is connected to VDD. We can directly short this one with VDD. So paint M1. Our layout should exactly represent the twisted transistor model, the twisted diagram. Now select this area, type paint and diff. Now this is the end diffusion layer. After this we have to place a poly. That is a 4 width, so let us make it 4 width. Type paint poly. Okay, this is 5. This became 5 layer. Let me undo. Type paint poly. Now the two gates are shorted. Similarly, we have to short the type paint M1. Now remove this extra portion by selecting the area and type erase. Okay. Now we have to short the source of this NMOS to ground. Select the area and type M1. Paint M1. Okay. Now we have to extend this layer. Type paint M1. We have to place a contact over here. Select the area and type paint. The contact here is N diffusion contact since this is a NMOS. So type paint NDC. Here also select the area, type paint NTC. Similarly, over here, select the area and then type paint polydiffusion contact. So type paint PDC, paint PDC. Now we'll place some more contacts over here. So type paint PWL contact PWC. Here also type paint PWL contact. This is NWL, so NWL contact, and here also NWL contact. Okay. Now our layout is not complete yet because this is my inverter separately. This is my NAND layout separately. Let me zoom out. You can see this is the NAND part. The portion I select is the NAND part. This is the NAND part and this is the inverter part. So we have to connect the output of the NAND gate, which will be the input of the inverter. So output is a metal layer, inverter is the input of the inverter is a polysilicon layer. So we have to connect it and then place a contact. Type paint poly. Paint M1. Now they are overlap and they have to be connected by a poly contact. Poly contact. This is the poly contact. Now the design is complete. After this, after drawing the layout, the very important part is to see whether there are any DRC errors. See DRC. It's DRC find. It's saying there is no errors in unnamed because we have not saved the layout yet. So write save the layout as and Now when I write DRC fine, it's showing me there are no errors in AND 2. Now this is the layout of the AND gate. Now we have to label the source, the ground, and the inputs and outputs. So this is my VDD. Now zoom in. In order to label, select a area and right click on the bottom left and then type label VDD. If you zoom in, you can see this is VDD. Similarly, this is label ground. This is the input, label A. Label B. This is the output, label Y. Now type save and 3 in order to save the changes made to the layout. Type and save and 2. Now type extract all, extract to spice, and then exit. Type vi and 2.spice. Earlier, this VDD, ground, all these were not shown since we had not given the label. So this is metal 1, this is the MOSFET 1, VDD B A underscore 39. This VDD is the drain terminal, this is the gate, and this is the source. Now type WQ. Now again, if you want to see the layout, then type magic and 2.mag. This is the layout of the AND gate. This is VDD, ground, A, B, and output Y. This is the final layout of a AND gate, two input AND gate. After saving the layout, find the DRC errors and then type extract all. So now the magic file, that is and2.mag, has been converted to and2.ext. Now type extract to spice. It's ext to spice. Now extract to spice finished. If you want, you can see the files over here. This is and2.spice. If I open this, you can see here it's written M1000. This M stands for MOSFET and this is for PFET. PFET means the P MOSFET. This is similarly the N MOSFET. Here 80 specifies the area of diffusion, that is 84. PD shows the perimeter of diffusion layer. Similarly, AS is the area of substrate, PS is the perimeter of the substrate. This is for the first PFET, this is for the second PFET. This is the magic file, this is the extracted file. Now we will learn how to draw the layout of a 2-input AND gate without using the commands. So at first, open the terminal window by pressing Ctrl Alt and T. Then type magic. Here we will not use any commands in the Tickecon window. We will directly use the toolbars and the keys in the keyboards. So instead of typing grid, we will enter G from the keyboard. Then go to options and toolbar. So here are the N-well, P-well, then N diffusion, P diffusion, etc. So at first we have to create the P-well, the PFET region. So select the area and middle click on the mouse. Now select the area and middle click on the mouse for P diffusion. Okay. Now this is the PFET. Now create the layer for VDD. That is the metal layer. Now middle click on the metal layer. Now create the NFET region. Select the area and middle click on the N diffusion layer. Similarly, we have to create a ground layer. middle click on the metal one. Now we have to short the source of pfet 1 with VDD. Let me increase this. Okay, now this is connected to VDD. Similarly, the pfet2 has the source of pfet2 has to be connected to VDD. Now, if you want to omit any part, select the portion and middle click anywhere outside. Similarly, we can connect this to ground. Okay, now we have to create the two inputs. Select the area, middle click on poly. This is input 1. Similarly, we have to create input 2. Okay, now these are the two inputs. These two are VDD, this is ground. Now we have to remove this extra portion over here. Okay, that we'll do later on. This is the common drain of the pfet that has to be connected to the drain of NMOS 2. This is metal, metal, and metal. Select the extra portion, remove it. We have to extend the metal layer over here. Okay, let me undo it. Yes, now this is uniform. Okay, now select the area. Since this is the P diffusion layer, we have to select the P diffusion contact, that is PD contact. Similarly over here and here the N diffusion contact. ND contact, ND contact. Here also there should be a P diffusion contact. Okay, and here we have the N-well contact, N-well contact is contacts are from here. This is the poly contact. So in the commands we were writing NWC, that is N-well contact. Over here we will use N substrate contact. This one, N substrate contact. The N substrate contact. Now these are too nearer. Let me undo it. Okay. There should be always uniformity in your layout. So this is N substrate contact. Now similarly place the P substrate contact over here. P substrate contact. Another P substrate contact. Let us zoom out. So now the NAND part is done. We have to move to the NOT part. So let us extend this. Metal. We can directly middle click over here or directly from any metal contacts, any metal layers. Now select the area and then middle click on the anvil. Now this is anvil and this is the P diffusion. P diffusion layer. This is the P diffusion layer. Now the VDD, the source has to be connected to VDD. Now select the area, this is metal. Now I have to create the this region, the NPET region. Now middle click on the end diffusion layer. Similarly, we have to connect this to ground. The source of the NPET has to be connected to ground. Extend this layer. Okay. Now this is ground. This is VDD. We have to short the poly. By poly layer, we have to short the two gate terminals, and the two drain terminals have to be shorted in order to obtain the output. Middle click on metal. We can see there is some extra layer, some extra portion of end diffusion. Okay, now after placing the other contacts, we have to place the P diffusion contact, PD contact, P diffusion contact here also, PD contact. After that, since this is the end diffusion layer, select the portion and then place the ND contact. Similarly, select over here this portion. We place these contacts because here we can see the end diffusion layer and the metal layer, they're overlapped, and we need to connect these two. If we don't place a connector, then they will remain unconnected. Place the ND contact. Okay, similarly we place some more P substrate contacts. P substrate contacts. P substrate contact. Similarly, we place another N substrate contact over here. Okay, now let me zoom out. Yes, so this portion is my NAND gate and this portion is my inverter. Now these two are separately NAND and NOT, but we have to connect it in order to obtain our AND gate. As we know, NAND plus invert gives AND. So we have to extend this poly layer. We have to connect the output of this to the input of the inverter, and then middle click on the poly layer. Okay. Now we also need the metal over the poly. Since we need some connections, we need the connection. Now place a poly contact over here since the poly and metal layer are overlap. Now this is the complete circuit of the two input AND gate. Now next thing is to first save the layout. So type and 3. save and 3, DRC find in order to see the DRC errors. This is a VDD layer. So now we have to label. So type label VDD, then label GND. Now this is my VDD layer. Now label the inputs and outputs. This is input 1, so type label A, then label B. This is the output, so type label Y. Now save and 3. Now extract all and extract to spice. Now all the extractions are over. Now let's exit. If you want to see the layout of the AND2 gate, then type magic and 3.mag and then press enter. Now this is the layout of the magic AND2. Press Z for zoom in, G to grid in. You can see this is A, this is B. So overall this is the layout. Now we will learn how to draw the layout of a 2-input AND gate without using a full layout of NAND and a full layout of NOT. We will use NAND as a cell, as an instantiation in order to draw the layout of a AND gate. So open the terminal window by pressing Ctrl Alt T, type magic, now let me clear this. Now type get cell. Earlier NAND 4 was designed as it was a 2-input NAND gate. So type get cell NAND 4. So now you can see a cell over here named NAND 4. In order to see the in order to see what is inside the box, select everything and type X. Now zoom in and you can see this is the NAND gate that we had designed. Now we have to design a inverter. To design an inverter, first type grid, Then let's zoom in. First create a anvil region. Type paint anvil and then a P diffusion layer. Type paint pdiff. So we need a VDD. We can extend this layer by typing paint M1 from here. Type paint M1 since this is our VDD. So directly the source is connected. The source of the PMOS has been connected to the VDD layer. Similarly, we need a NMOS. Select the area and type NDiff. Now the source of this has to be grounded. So let us extend this metal layer. Type paint M1. Now this is a ground layer. You can see it from here. This is the ground. Now the source of the NFET is also grounded. So type paint M1. Now VDD ground over. Next is the poly layer, the connection of the gates. Type paint poly and here type paint M1. The extra portion can be erased. Now we have to connect the output of the NAND as the input of the inverter. So let us extend this metal layer. Type paint M1 and over the metal layer we have to place the poly layer. So type paint poly. If we want we can also extend this. Type paint poly. Now this is the poly contact. Type paint poly contact. Similarly we have to place here the other contacts. Paint PDC. Here also PDC. Paint PDC. Paint NDC. And here we have the P well contact, paint P well contact, paint and N well contact, paint and well contact. Now we can save it as save and 4. Okay, and this is our final output. So let it be out. We'll name this as label Y. So this is the output of a NAND gate. This is the output of the OR gate. In the similar process, you can type extract all, extracting NAND 4 into NAND 4, extracting AND 4 into AND 4.axt. Because we have taken as instantiation, so we can see there are two extractions. Now extract to spice, extracts to spice finished. Now let us exit. Type vi and 4 dot spice. So you can see here the pfit, there is a path written over here. The others remain the same type, but there are many changes due to the instantiation. So you can see here NAND 4 underscore 0 slash VDD. Directly VDD is not written. NAND 4 underscore 0 slash VDD, because if you remember, the instantiation was NAND 4. Below it was written NAND 4 underscore 0. It was the instance name. Similarly, NAND 4 underscore 0 slash A, and similarly over here NAND 4 underscore 0 slash VDD. If you want to see the layout again, type magic and 4 dot mag. So now you can see this is the NAND. The portions that we have added is written separately. It is seen separately. Now select this one and type X. If type X, then you can see the whole layout. You can see the shaded portion is your instantiation and the unshaded portion is your drawn layout. So this is the layout of the AND 2 by using instantiation.